For this video, we'll be giving examples on basic set operations. So the first is on union. So say we have set A with elements 1, 2, and 3, and B with elements 4, 5, and 6. So if we are asked to find the union of this set, what we simply do is we add the elements in both sets. So in this case we have 1, 2, and 3, 4, 5, 6. So that's simply 1, 2, 3, 4, 5, and 6. And that's their union. So let's say, what if they have a common element? So say for example, their common element is 2 and 3. So what we do out here is that we still add their elements, but we don't repeat their common elements. So what I'm saying is their union would be 1, 2, 3, and 6, since that would just be redundant if we repeat 2 and 3. So next, let's say for example, the elements are, in B, the set B refers to the empty set. So what would be their union? Their union would simply be 1, 2, and 3, or simply A. So why is that? It's because it's simply like referring to, say A is some number, say 3 plus empty set 0. So their sum is still 3. So now, what about if we have B as U, or the universal set? We refer to set B as the universal set. So what would be their outcome? Their outcome would simply be U as well. So why is that? So let's say, as an example, a real example, say U is equal to the set of all real numbers. So what would be the outcome when we add the set of all real numbers plus set 1, 2, and 3? So the outcome will still be all real numbers, since these real numbers already contain 1, 2, 3. So like our earlier example, it's a common element in the set of real numbers, so we won't be repeating it. So now let's go to discussing what intersection, examples on intersection. So for our first example, let's use letters this time. Let's say we have A, B, and C. And the set B contains B, C, and D. When we get their intersection, we simply get the common elements. That in this case it's B and C. So that's simply B, the set containing B and C. Now what if they don't have a common element? So let's say this one is E and F. So their outcome, their intersection, would simply be the empty set, or you can also denote it with a bracket without an element in it, since they don't have any common elements. Now, what if B is the empty set? What will be the outcome of their intersection? So their intersection would also be the empty set. since, like our previous example, they don't have any common elements, so it's simply the empty set. Now, what if B is equal to the universal set, U again? So their outcome would be the set containing A, B, and C, or simply A. So why is that? Because the universal set contains all the elements in the set. So A, like in our Venn diagram before, A is inside the universal set. So when we get their common elements, U has the elements of A. So their common elements is simply A. Now, let's go on discussing some examples on set difference. For this case, I guess let's use some words. So let's say a bag and a pen. And the set B contains the pen. So when we get their difference, A minus B, we simply remove the elements that is present in B. In A, so pen is present, so we remove that. So the outcome would only be a bag. Now what if the elements in B contains other elements such as pencil and paper? Would the outcome of A minus B change? The answer is no, because the common element is still pen. So the only thing that we remove here is pen. We can't remove pencil anymore here, so since it does not have pencil, we can also remove paper. So the outcome is still the element or the set that contains bag. Now what if, say, B? What if B does not contain any element similar to A? So let's say some random, say A and C, that letters. So what will be So what will be the outcome of A minus B in this time? So the outcome is still a bag and a pen, since there's no elements that will be subtracted from B. It's the A. So for last example, let's say B is the universal set. What would be the outcome of A minus B? So for this case, the outcome is an empty set. The reason being is, as I said a while ago, the universal set contains all the elements. So that includes bag and pen for this case. So both of these would be removed in this case. So the outcome is an empty set. Lastly, we discussed some examples on complement. The set complement. So say for example we have let's say the universal set is the set that contains V, W, X, Y, and Z. So what would be their outcome if we say that A is equal to V, W? So when we are asked to get the A complement, we simply get the elements that is not present in VW. So these are these three elements. So it will be the set containing X, Y, and Z. Now, what if we are tasked to find the complement of an empty set? Or we can also denote it by the two brackets, complement. What would be the outcome of this? So since the empty set is set where there are no elements, its opposite is the universal set. Because the universal set contains the set that contains all elements. An empty set does not contain any element. Similarly, when we find the complement of the universal set, the outcome is the empty set, since this contains all elements and no elements for the empty set. So now let's try some harder examples, some combination of these. So for this one, say we are given the set U, which contains 1, 2, 3, 4, 5, and 6. The set A, which contains set A, which contains 1, 2, and 3, and the set B, which contains 4, 5, and 6. So, what if we are tasked to find this one? This is A union B complement minus the intersection of B and A complement. It would be its outcome. So to get this one, we simply start with both parentheses. Since PEMDAS, we also apply that idea here. So we start first in this parenthesis. So we know that A is 1, 2, and 3. First, what is B complement? B complement is simply A, because the elements that are not present in B is present in A. So this is simply A union A. And this one, what is A complement? Similarly to the first one, A complement is simply the elements that are in B is equal to B, because it does not contain 4, 5, and 6. So this one is simply B intersection B. Now, so first we think, what is A union A? A union A is simply A, because as we said a while ago, we simply add their elements, but they have the same elements. So we don't repeat the elements, because as I said a while ago, that is redundant. Now B intersection B now is equal to B, because 4, 5, and 6 intersection 4, 5, and 6 would still give 4, 5, and 6, so since they both have the same elements, so their common elements is the whole set. So let's rewrite this one. So basically, after simplifying, what we are just finding here is A minus B. Since A does not contain any elements that are common in B, we won't subtract any elements in A. So the outcome is simply 1, 2, 3, or 8. So the final answer for this one is simply A. So through our lessons and our examples, we found out that given a complex problem, you can simply simplify it to a shorter one, or simply like this one, just one element, which is A. For our last example, given this one, A union B complement intersection C complement minus A complement intersection B union C complement. So we're tasked to find this one. At first glance, it might seem problematic because we won't give any examples here. So unlike before, we have set A equals 1, 2, 3. In this case, we won't give any of that. So how do we solve these types of problems? Let's first, like a while ago, we focus on this first one. So what is A union B couple? This is simply, by De Morgan's law, this is equal to A complement intersection B complement. And what is B union C complement? This is simply B complement intersection C complement. So what we did here is we applied the De Morgan's law. Now we bring this down as well as this one. So that will be this one minus A complement. So at this part, maybe you are already noticing that these two expressions are similar. Now note that in intersection and in union of sets, these are operations that are commutative and associative. So basically we can remove the parentheses out here since all of these operations are already intersection. So this would become A complement intersection B complement intersection C complement minus A complement intersection B complement intersection C complement. So now these two are already the same. So when we subtract them, the outcome is simply the answer. That's all for this video.